this lesson, I want to introduce you to some syntax tips that we can use to make our code more readable and elegant. Now, VBA greatly helps us write our code. It already includes certain built-in features to make our code more likely to be readable. For example, VBA automatically inserts spaces between operators like the plus sign and the minus sign. VBA also auto-completes certain parts of the code for us, like the end sub keywords at the end of a procedure. VBA will also adjust, for example, the casing of letters in things like our method names and our procedure names to avoid any kind of issues with case sensitivity. VBA, of course, will also scan the code for errors and alert us whenever we run into any kind of technical, syntactical issue. So VBA is automatically helping us, but there are other things that we can do just to ensure that our code looks prettier and that it's a lot easier to read as well. I'm going to go ahead here and define a new procedure. I'm going to call it do stuff. And I'm just going to use this procedure to demonstrate a couple good habits and a couple bad habits when it comes to code. So in many programming languages, we have the concept of a semicolon, and a semicolon is typically used to break up or terminate a statement. And actually, VBA allows us to use semicolons in order to execute more than one statement on a single line. For example, I can do something like this: debug print, let's output the word hello. Then I can put a semicolon, and a semicolon almost acts like a line break because it terminates the code that comes beforehand. So it sort of says, this is the end of the code that I was just about to write. This is the end of the statement that I'm about to make. So we can go ahead after a semicolon and write a brand new command. So now we have two commands on a single line. With that said, this is not considered best practice. The first tip I have for you is that each VBA line should consist of one instruction or command. So whenever you want to put more than one command, break them up over multiple lines, and in general, avoid the semicolon. We don't need to put the semicolon because the line break will serve essentially as the end of the statement. VBA and the editor is able to parse that as the natural conclusion of our command. Here's another tip I have for you. Let me just go ahead and comment out the code. Many times, whenever we're writing something like a fully qualified reference, for example, referencing all of the parts of the Excel object model, we're going to run into a line of code that's very long. For example, let's say I have a value here in cell B. Let's just make it the letter B. And let's say I have a value here in, actually, let me move this up. Let's put a B in B1 and an A in A1. Let's say I want to move the value B into cell A1 with VBA code. So I could write something like this. This is going to take a little bit, but we're starting with application. We're referencing the first workbook in the workbooks collection. We're referencing the first worksheet. We're getting the range of A1. We're getting the value, and we want to set this equal to the value in cell B1. So what I can do is actually copy this entire code right here, paste it to the right, and make this work. So what we're doing here is we're taking the value from cell B1, getting it, and then, of course, making that the value in cell A1. Now, this is functional, but of course, this line becomes really difficult to read. So how can we break it up? Well, we can actually use the underscore to break up lines in VBA code. So for example, right here after the equal sign, I can put an underscore and a space. I can break this up, and when I execute this with F5, we can see that B has replaced the value in cell A1. So the macro has run as expected, which means that this is not leading to an error. So essentially what the underscore does is it tells the VBA parser that we're going to create a line break that's intentional and that it should continue parsing the line as if it's still on the same line. So it's going to read this thing on the right side of the equal sign as if it's written right here. It's just a little syntactical tip that we could use to break up things over more than one line. In fact, what we can also do is create a line break after an object reference. For example, if I were to drag this line back to the one above, so let's go ahead and remove this, drag this up. Right here, I created my line break right here, but I could actually do it right here after this dot. I can put a space and a underscore, move this to the next line. Let's just go ahead and change this back to H so that we can make sure everything's working. When I execute this, click in here, click F5, we can see that everything is working as expected. So we can create a line break actually in a wide variety of places. We can also create a line break, by the way, after the comma whenever we are entering multiple arguments to a method. That's a very effective use case. So I'm going to be using this sometimes throughout the course when I'm going to write a line that's going to be very long and I want to cut it down. What I can do is keep the logic but break it up over multiple lines by using the underscore. All right, let's go ahead and comment this code out. And there's one more tip I want to show you in this lesson. Sometimes we're going to be dealing with text that includes a double quote. There's just one problem. VBA uses the double quotes to mean something. It means the beginning and end of the string. So what do we do when we actually want to use double quotes within a string? For example, let's say I have a quote here like, Romeo said, I love you, Juliet. Let's say this is a string that we want to write into a cell. We're going to run into a problem here because we have a double quote here, and VBA is going to interpret that as the start of the string. But before it gets to this last one, what's going to happen is it's going to interpret this one as the end of this first string, and we're going to run into an error. So let's see if we can debug print this and see what happens here. Should run into an error here, so when I execute with F5, you can see variable is not defined. VBA is getting confused about what this means. So what do we do whenever we have to deal with quotes in our text? The first thing I want to do here is actually get out of this thing, which is called our error handling. Whenever you see this yellow, it just means that we're entering into a debugging mode. We can click this blue square to stop that and reset our code. So right here, let's just go back to what we used to have. I love you, Juliet. All right, so this is what we wanted to do. What we can actually do is we can use a second double quote before any other double quote that needs to be part of the string. It's sort of an escape character if you're familiar with that in other programming languages. But what I mean by that is we want to ignore this double quote. The way we do that is by putting another double quote before it. So VBA recognizes two double quotes in a row as sort of a sequence that it recognizes as a regular quote. So we're not going to run into an error. So we have to put one more double quote, and that's going to be right here. So this is going to be 3 in a row, but just as a review, these two are going to translate to a single double quote because 2 in a row indicates that VBA is going to escape the next one, so it's going to understand that it's part of the internals of the string. And finally, this one at the very end is actually going to end the main string that's being output by debug print. So if I execute this, there we go. Now everything's working. We just have an extra semicolon there somehow. Let's go ahead and try this again. Let's try this. F5. There we go. So now we can see Romeo said, I love you, Juliet is being output, including with the quotation marks that we have intentionally put there. We simply escaped them or avoided them causing an error by placing another quotation mark before them. That's the symbol that we use. That's all there is to cover in this lesson. We talked about using quotation marks, we talked about writing one statement per line only, and we talked about creating line breaks with the underscore character, which is probably going to be the most important tip that we learn here. I'm going to be using that a lot throughout the course. That's all there is to learn here though, so I'll see you in the next lesson. In this lesson, we'll talk about variables, which are a very important part of VBA programming. A variable is just a placeholder for a piece of data in our program. Now, what do I mean by a piece of data? Well, data can mean anything from a number to a piece of text or a string to a complete VBA object like a range or a workbook or a worksheet. A variable is just a name that we choose as a developer that points to a specific object in our program, so we don't have to reference that object over and over and over again. So if you think back a while ago when we talked about fully qualified references, for example, when we used application and then workbooks and worksheets to reference a specific range object, that process of writing out that reference can take a while to write out. It's much easier to just write it out once and assign that final object reference to a variable, which again is just a placeholder name, and then reference that variable instead of writing out the entire object reference again. So variables are just simple ways that we can refer to something in our program without having to remember exactly what a specific value is or a specific object is. So let me go ahead and create a sample variable here for you. There's actually two parts to a variable. The first is the declaration, and the second is the assignment of a specific value. So the declaration, which is the first step, is the part where we tell VBA that we want to allocate a piece of computer memory for a variable. We're going to say, we're going to define a name here, a specific variable, which is just a name, and we also have to tell VBA the kind of data that it's going to hold, so that when we assign a value to it, VBA is prepared to store or reference that specific kind of data. So let me go ahead and create a brand new procedure here. I'm going to call it my first variable. And as soon as I add the parentheses and press enter, VBA will complete the end sub. So what I'm going to do here is write out a single variable declaration because it's a lot to take in at first. So I'm going to write it out completely and then go through it step by step. So here we go. Dim age as integer. As soon as I do a line break, perfect, there it is. The first part here is the dim keyword, which is actually part of VBA. It's a keyword within the language. Dim is short for dimension, and that's an old school computer science term for variable. So dim always has to be written before we write out any of our variables. So if we had more than one variable, we always place the dim keyword before the actual name. So immediately after the dim keyword, we write the name of the variable. This is our own decision. This is up to the developer. And ideally, the name should describe what the variable is going to hold. So in this case, I want a variable that's going to store my age. Let's say I don't want to remember it. I just want to store it in a variable once so that I can always reference age later in the program and know that it's always going to give me the actual numeric value of my age. So age is up to me to decide. In terms of the variable name, I've chosen age. That's the second thing I put in this sequence of 4 items. Immediately after the variable name, I put the keyword as. That also is part of VBA, and that also must always be included. And finally, at the very end, that's where we declare the variable type. This means the type of data that is being stored. We have, as I mentioned, many different types of data. We have integers, we have strings, we have complete VBA objects. We have to tell VBA, in order for it to allocate memory, exactly what we plan to store in this variable. In this case, age is going to be an integer. As a basic mathematic review, an integer is just a number without a floating point component. So a number without a decimal, a whole number like 5 or 10 or 15. Earlier on, when we were looking at some of the configuration settings in the Visual Basic Editor, we enabled an option that mandates that option explicit appears at the very top of each of our modules. This option explicit setting mandates that every variable be declared before we actually assign it a value. And when we say variable declaration, that's this part. We are declaring, we are telling the program as a statement of fact that we are going to have some kind of variable called age in this procedure, and that we expect age to be of an integer type, a whole number. But we haven't actually assigned it a value yet. We don't know what age is equal to. We just tell VBA to spare some memory for it. Now, there are a couple restrictions that VBA places on our variable names that I want you to be aware of. The first is that variable names cannot be greater than 255 characters. You're generally not going to run into this problem with your variable names, but I did want you to be aware of it. Variable names, exactly like procedure names, cannot contain spaces. So if you have multiple words, you can stick with the upper camel case syntax, which means the first letter of every word can be capitalized, and you can use that to sort of mark where a new word begins. But you cannot have actual spaces in your variable names. Variable names also cannot contain mathematical symbols like plus or minus. They cannot contain any kind of punctuation characters like the question mark or the exclamation point. They cannot contain special characters like the hashtag. And they cannot be reserved VBA keywords like sub or end or option or explicit or worksheet. So don't create a variable called worksheet. The variable actually has to be some kind of name that isn't part of the VBA language. The variable must also be unique in the procedure that defines it, which means we can't declare another variable called age in the exact same myFirstVariable procedure. So that's going to trigger an error in VBA. However, we can have the same variable names across different procedures. So if I had another procedure below my second variable and I declared a variable called age in there, that's totally valid. And age in my second procedure can be a totally different data type. The reason we can do this across different procedures is because the variable has this concept of scope. And scope refers to the limit or the reach or the boundary in which a variable exists. And a variable only exists as long as the procedure is running. So every time my first variable is executed, it's going to create a variable called age that's going to be an integer. But as soon as that procedure is done, that variable is tossed out of memory. It doesn't exist any longer. So whenever we run a second procedure that also has a variable called age, that second variable is simply going to be created from scratch. And that process continues over and over and over again. Finally, we cannot start a variable name with a number or an underscore. The variable name can contain a number or an underscore, but it cannot start with it. So the general best practice to follow is to start your variables with a letter and just make it as descriptive as possible. It should describe the actual value that it's holding. So age is a pretty good variable name. You don't want something like num or num1. You don't just want to say it's a number. You want to describe what it actually is, what it actually represents. So now that we've declared the age variable as a type of integer, we can actually go ahead and assign it a value. The way we do that is on the line below. We write the name of the variable. This is age. This is our own custom name. We give an equal sign, much like if we were assigning a value to a property of an object, just an equal sign. And then on the right side, we write the actual value that we want to assign to this variable. So let's make the age variable equal to 26. So what does this mean? Well, age is now a placeholder, and it's a placeholder for a number of 26. That means that I can reference the variable age anywhere in this procedure's code, and it will give me the value 26. It's a representative of that value. It's a placeholder over it. So for example, if I wanted to debug print, rather than writing 26, I can simply write age. And whenever VBA evaluates this, it's not going to print the literal string age. Rather, it's going to say, hey, you have a variable here. What is that equal to? Oh, right here it's defined to be 26. So I know that it's a reference to that number. So this is going to evaluate to 26. So when I execute this procedure, 26 is going to print in my immediate window. Remember that age is a variable that represents a number, but we're not limited to simply outputting that variable. We can do any kind of operations that we would do with a plain number. So for example, if I want to message box and I want to see what my age will be in 4 years, what I can do is age plus 4. The reason I can do this is because age is just a name for a number. It represents, it's a placeholder for the value that I assign up here. So when VBA is evaluating this, it's going to substitute age for the value it's assigned up here, 26. It's going to add 4 to get 30, and once it evaluates to 30, that's what message box is going to output for us. So when I execute this, a message box with 30 is going to appear in the middle right here. One last detail. VBA is not case sensitive, which means a variable with a capital A and a variable with a lowercase a are the exact same thing. VBA will generally try to correct you whenever you use the wrong case. So for example, if I try doing something like this, if I try typing age with a lowercase a, you can see it's automatically going to boost it back up to an uppercase A because it identifies that that variable exists. But VBA is not case sensitive. So in case of any kind of error, do not declare variables with the same name but different casing. VBA will try to correct for it, but you should avoid it as a general practice. If you want another variable, find a completely different name to give it. That's all there is to cover in this lesson. Variables are just placeholders or names that we assign to pieces of data in our code. Right now, I'm sure you're not seeing the big benefit of this, but rest assured variables are really helpful when we get to the nitty-gritty of actually accessing values on our spreadsheet, manipulating them, overwriting them. Variables help simplify the process of referencing complex objects. That's all there is to cover here, and throughout this entire section, we're going to be diving a lot into variables and the various data types that we can use in our code. It's an important foundation to lay before we start diving into the actual parts of programming in VBA itself. In this lesson, I want to explore a shorthand syntax for declaring multiple variables at once. In my Visual Basic Editor, I'm going to declare a procedure called moreVariableFun. And let's say in this procedure, I want to declare 3 variables: age, lottery number, and sheet count, and all 3 of them will be integers. The easiest way to do this is just to declare a different variable on every single line. So I can do something like dim age as integer. On the line below, I can do dim lottery number as integer. And finally, the same thing as sheet count. As a review, we always begin with the dim keyword for dimension to declare a variable. We follow it up with the actual variable name, like sheet count, followed by the as keyword, which allows us to declare a data type that variable will store, and finally the actual data type itself, which again will be an integer. Now this is completely valid VBA code. There's nothing technically wrong here, but as we can see, this takes up quite a bit of space. It takes up 3 lines of code. What we can actually do is simplify this a little bit by writing our code like this. I'm going to actually comment out the lines above so we don't run into any compiler issues. Right below, we write the dim keyword once at the very beginning. Then we write each variable declaration along with its type declaration. So dim age as integer. After each one, we put a comma to separate each variable type declaration. So age as integer followed by a comma, then lottery number as integer, another comma, and then sheet count as integer. And that way we can place multiple variable declarations on the very same line. They also do not need to be of the same data type. In this case, they coincidentally are, but you can have a declaration of an integer and then a string and then some other kind of data type on the same line. The only convenience here is that you can declare them all on a single line instead of having to split them up over more than one line. Now, there's one common mistake that beginners make whenever they're trying to emulate this syntax in their code. The syntax as it's shown here is completely valid. One dim keyword at the very beginning, followed by each variable and its type declared, separated by commas. However, many times people do this syntactical error whenever they're starting out. They write something like this: dim age, comma, lottery number, comma, sheet count as integer. This is a little bit deceptive because you would think that VBAs would figure out that we want all three of these variables to serve as integers. But what's actually going to happen here is that only sheet count is going to be declared as an integer type. Because age and lottery number are not given explicit data types, they're going to assume a data type of a variant. Now we're going to dive into the variant data type later in this section, but essentially it's a catch-all data type. It's a chameleon data type that can essentially serve as anything: a number, a string, an object, anything. That sounds like it's a really good thing, and sometimes it can be, but it's also very inefficient. If a variable has to be able to represent any kind of data, it has to take up a lot more memory. So we want to avoid the variant data types, the default one, as much as we can to make sure that our program is as efficient and quick as possible. Whenever we don't give an explicit data type with the as keyword, VBA will assume that that variable will store a variant data type. And in this case, even though we think that age and lottery number will be represented by this integer syntax, this as integer syntax is only being applied to sheet count. So we have two variants being declared here and one integer being declared here. This syntax can be very dangerous and can make the program much more likely to run into error. So be very careful whenever you are declaring variables on one line. You have to remember to use this syntax. One thing I like to do is to declare all variables on a single line like this, and then start consolidating them into a single line. So just place a comma at the end and then start deleting the dim keyword from the next line. And that way, if all you delete is the dim keyword, there's no way you can make a mistake because you're still going to keep each variable name and each variable declaration, which is critical, okay? That's all there is to cover here. We talked about variable declarations, more than one at a time on a single line. That can help us save a lot of space and make our code better looking, more aesthetically pleasing. In this lesson, I want to talk about the option explicit setting. As it turns out, VBA can enforce mandatory declarations for all of our variables. This means that every variable must be declared with the dim keyword before a value is actually assigned to it. Now, we added this setting earlier in the course, but I want to explore it now in more detail because we know a little bit more about variables. So every module that we've created so far, we've seen these two words at the very top, option explicit. If I go up here to Tools and Options, this setting is enabled right here by this require variable declaration check. If we check this option, and that's what I recommended, whenever we create a brand new module, these words will be added to the top of the module. For now, I want to demonstrate how the code is going to work if we remove this option. So I'm going to uncheck this, click OK, and then I'm going to remove option explicit up top here. What I'm going to do here is declare a procedure. I'm going to call it undeclared. And let's say I have a variable here, and I'm going to call it my number. And now what I'm going to do automatically is just assign a value to my number. I'm going to make it equal to 15. This is valid code without option explicit, and this is not a good thing overall. Why not? Well, for two reasons. One, we haven't been explicit about what kind of variable type my number is. And whenever there is uncertainty, whenever things are implicitly assumed, there's always a chance of greater error. The more that we explicitly declare variable types, the more that we say to VBA, this is going to be a number, this is going to be something else like a string, the less likely our code is to run into errors. From a human perspective as well, it tends to be better because whenever we read code with explicit variable type declarations, we have a better understanding of what's going on. Sometimes developers, for example, fall into a habit of using bad variable names like X or A or B. And sometimes when we're reading through code and we have no context, we see a variable called X, we don't know what kind of data type it is, we just see it being assigned. Sometimes it may be accidentally assigned to two different data types. First it's going to be a string, then it's a number. All of those things add confusion to our code and make it more difficult for ourselves when we come back to it, as well as other developers, to understand what's going on. So being explicit about what kind of variables we're using is a good practice overall. It'll make you a better developer. Now, without option explicit at the very top, this is valid code, so I can execute this macro with the F5 keyboard shortcut. Nothing is going to happen here. But again, we're more likely to run into errors, so we want to get rid of this feature. So again, how can we do that? We can go to Tools, we can go to Options, we can select Require Variable Declaration. One thing to point out here is that when we click OK, option explicit will not be automatically added. It's only going to be added whenever we create a brand new module. For example, I can create a new module here, and there it goes, there it appears. So if you ever find it absent, you can actually manually type it in at the very top of the module. So I'm just going to add option explicit here. And now notice what happens when I try to execute the procedure again. If I click F5, we're going to get a big error box pop up, and it says variable not defined. My number has not been declared, it's just been assigned. So VBA is pointing out that mistake to us. That's really beneficial to us as developers because we have this reminder now of, hey, we forgot to declare what my number is. So we can click OK here, say, all right, let me get out of this debugging procedure. I can click the reset button right here to exit out of that little thing. And then I can say, all right, so I know I'm going to need a variable that I'm going to use here in this procedure. I'm going to call it my number, and it's going to be, let's say, an integer for now. We'll dive into this data type very shortly, but that just means a whole number. So now I've declared a integer variable. We know that my number is going to represent a number. We're now assigning a valid number. There's less chance of the code going in the wrong direction because we can't accidentally assign something like a string. So when I execute this, we have no errors, but let's say sometime later, maybe we have a long procedure with 30 lines, and I think my number is supposed to be some kind of string like hello. When I execute this, we're going to get an error. It's going to be a type mismatch, which means that the type that the variable is expecting, which is an integer, is not what we've actually assigned. And that allows us to run into these bugs earlier, figure them out, debug them, fix them, and make the code more likely to run properly when it's actually executed by the end user. Now, I do want to point out that there are some limits to option explicit. Do you remember the code that we introduced in the previous lesson where we declared multiple variables like this, dim, age, lottery number, sheet count as integer? So as it turns out, this is not going to be caught by option explicit. Why not? Well, because we're still technically declaring the variables, right? The dim keyword here is going to declare an age variable, a lottery number variable, and a sheet count variable. The problem here is not with the variable declaration, it's with the fact that these age and lottery number variables are accidentally being declared as the variant data type. That's the chameleon data type that can represent any data type. But they're still being declared. They're just being declared, and VBA is implicitly assuming that they're going to be this variant data type. So unfortunately, option explicit will not catch this error. We have to be very careful here whenever we're declaring variables to avoid something like this and make sure that we always declare each data type right next to each actual variable declaration. All right, but that's all there is to cover in this lesson. We talked about the option explicit setting. It should be something you keep with you throughout your entire career as a VBA developer. It'll make you a better developer, and it'll make you a better programmer. It'll reduce the errors in your code. It might be a bit of a hassle sometimes because you're going to get started. You're going to be thinking really quickly, and you're going to just automatically assign a value to a variable. But then when you run the procedure, it's going to warn you and say, hey, I don't know what this is supposed to represent. Make sure you declare it. Make sure you tell me what kind of data it's going to hold, so then I can properly work with it. So option explicit is a setting that you should always keep in your Visual Basic editor. In this lesson, we'll talk about the byte, integer, and long data types. As a reminder, a data type refers to how a piece of data is stored in the computer's memory. We've briefly talked about the integer type of data before. That just represents a whole number. But as it turns out, there's numerous ways that we can store numbers within Excel. There are some minor differences between them that are kind of becoming more insignificant as computers grow in speed and processing power. But I did want to make sure that you understand that there are a couple options available to us and understand why these options exist. As another reminder, VBA does not explicitly require us to have variable declarations or type declarations, but these are both best practices. We always want to declare variables with the dim keyword, and we always want to tell VBA what kind of data type that variable will hold. That makes our programs run faster, that reduces inefficiency and reduces the chances of error. And with the option explicit setting at the very top, we have mandated variable declaration, which is a good thing to have no matter where we are in our journey as VBA developers. All right, so let's begin by creating a new procedure. I'll call this one assign some values. And in the body of this procedure, all I'm going to do is just assign a couple variable values and output them with the message box method. Let's begin with byte. So I'm just going to declare it at the very beginning. I'm going to call my variable b, just something short and sweet, but you can give it whatever name you want, dim b as byte. So it's spelled B-Y-T-E. BYTE or a byte is still a whole number, but it's the smallest bucket for a whole number available in VBA. So a byte can store any value between 0 and 255. So it's a really, really small packet of memory, if you will, and so it only supports a pretty limited number of numbers that it can actually hold, only 256. But predictably, the smaller the container, the smaller the amount of memory it takes up. So the byte is the smallest option available to us as a data type whenever we want to store a whole number. Next up after the byte is the integer data type, which we briefly talked about before. That was the one I introduced at first because integer is a very common term in mathematics for a whole number, but it's also an explicit data type within VBA. So I'll declare a new variable. I'll just call it I, again for simplicity, and write out integer. So the integer data type is similar to the byte. It supports whole numbers, but the range of numbers, the total bucket of values that it can support is a little bit bigger. So this one supports any value from negative 32,768 to positive 32,767. So a little bit of a wider range if you want that kind of storage capacity. Finally, the last data type available to us for whole numbers is called long. So let me type it out here, a variable of L. Again, just for simplicity's sake, the variable name is totally arbitrary. And let's declare a long variable. And this is the biggest container for a whole number that is available in VBA. And it supports any number from negative 2,147,484,648 to positive 2,147,483,647. Of course, you by no means have to memorize these capacities. Just realize that the amount that's available grows with each data type, starting with byte as the smallest and long as the biggest, but each one supports a greater bucket of potential values. Now, this used to be a pretty big concern way back in the day, maybe 20 years ago or even further, when computers had a lot of limited memory and developers and programmers had to be very careful that they used the minimum data type necessary in order to store a value. Otherwise, the computer would simply run out of memory and the program would crash. In today's world, obviously computers are much more powerful, and we don't have to really worry about Excel running out of memory when it's doing some kind of calculation like this. It takes a lot of effort and many mistakes in order to actually crash a VBA program. You're not going to run into any kind of error if you store a small value like 5, but you use a long data type instead of a byte data type. So the best practice among the VBA community is whenever you're using a whole number, that means a number without a floating point, no decimal component, no fractional component, most people will just stick to the long data type. Why long? Well, because it's the one that offers the biggest space for your number. A long can still support any number between 0 and 255. It can support anything that an integer can support from negative 32,000 to positive 32,000, but it also has that wider range in both the negative and positive directions. So we pick the data type that kind of allows us to capture any kind of number that we want, no matter the size. Byte and integer are more limited. So you don't have to use long all the time, but that's what I'm going to do throughout the course, and what you're going to find is that that's what you find in most VBA code because it's the most flexible whole number data type that's available to us. Let's now go ahead and just assign some values to these variables. Predictably, because there are data types that are placing constraints, if you put a value that is outside of that range, you're going to run into an error. For example, if you assign b to 1,000, which is outside of the range of 0 to 255, VBA will throw an error. So the other benefit of using long is that there's less of a chance to run into problems. So let's just assign a value to b. That's our byte. Let's do 4. Let's do I, which is an integer between negative 32,000 and 32,767. Let's just do 25,000 for simplicity's sake. And for L, let's do a big number. Let's do 1 million. Pretty wonderful number for all of us. All right, and we can just go ahead and actually output some of these values. We can use the message box method. So once again, message box, let's place a space. There's our prompt parameter that expects a string of what we're actually going to output in our message box. So we can do something like b is, place a double quote there to end the string. As a reminder, this b in there is not actually referencing the variable. This is just the static letter b. What I can do here is use the concatenation operator, which is the ampersand, and then add the value of the actual b variable, and that's just going to add it to the end of that string. I want to show you an interesting functionality here that we may not have seen before. We can actually use what's called a predefined constant here to create an automatic line break. So instead of having everything written on one line in our message box, the content will be broken up line by line. And the way we do that is we write this, VB underscore, that's probably short for Visual Basic, and then new line. Capital N, capital L, no spaces. That creates a line break, but we can continue writing the continuation of the message box expression even at this point. So this is the visual representation of the text. So whenever we see this in the message box, we're going to have a line break at that point, and then we can continue concatenating. So let's say, and I is, do another space. Let's now output the value of the I variable. That's our integer. And once again, let's add another line break. VB new line, capital N, capital L. One more time, we'll put the ampersand, and L is our long. That's our largest whole number data type. Let's output the value of L. When I execute this, once again by pressing this play button up here or the run button, the message box should appear in our main Excel interface, so it may jump out of the Visual Basic Editor. So let's run this, and there we go. We have our complete list. B is 4, I is 25,000, L is 1 million. That's perfect. And that's it. So that's all there is to cover. In this lesson, we talked about the 3 data types that are available for whole numbers. B, or a byte rather, is the smallest, integer is the medium one, and long is the largest one. I prefer, and I think most developers prefer, simply using long all the time. It allows you to store just the largest range of numbers, and we don't really have to worry anymore about memory capacity like developers used to have to worry several decades ago. Computers are simply too fast and too powerful to make that any kind of issue. All right, so that's the numeric data types available for whole numbers, and we're going to continue diving into more data types as we proceed throughout the section. In this lesson, we'll dive into the mathematical operations that are available in VBA. Now, performing basic arithmetic like addition, subtraction, multiplication is a big part of every programming language, and every programming language includes a series of operators to help us perform those operations. An operator is just a symbol that does some kind of operation. For example, the plus sign is the universal operator for addition. So in this lesson, I want to introduce you to some of these operators in case you're unfamiliar with programming and you haven't seen them before. In this brand new workbook, I'm going to create a new procedure in the module I've created. I'm going to call this procedure Fun with Math. That's what we're having here. Let's just make sure it's a parentheses at the end. Perfect. All right, so I'm going to declare 2 variables. They're just going to be long variables, which means just a whole number data type. So I'm going to call them A and B for simplicity's sake. So dim A is long, dim B is long. We're declaring the variable. We're assigning it a data type, very important best practice. And let's just assign 2 values to them on the lines below. The variable A is going to be assigned a value of 4, and the value of B is going to be assigned a value of 3. And right below here, I'm just going to issue a series of debug print methods and just give them various mathematical calculations to perform so we can take a look at the operators that are available. Let's begin with addition. I'm sure we've seen this one before, but we simply write debug.print. We can give some kind of expression to evaluate. And the way we do this is simply the first value, the plus sign, and the second value. So the values on the left and the right side of the operator, the A and B, are called the operands. That's O-P-E-R-A-N-D-S. And the actual symbol that we're using is called the operator. That's what's making the impact on those 2 operands. So the plus symbol is the universal symbol for addition. So this is going to add 4 plus 3 together. Right below, we can subtract the 2 of them. The symbol for subtraction is the minus sign, so sometimes that's called the subtraction operator, just like the plus sign is called the addition operator. Right below here, we can do a little bit of multiplication. So it's going to be A. The symbol for multiplication in programming is the asterisk, so that's going to be Shift 8 on most keyboards. So this is going to multiply together 4 and 3, should give us a value of 12. And let's just do one more debug print before we run this procedure. Let's do division. The division sign is the /. So this little symbol on the keyboard should be on the bottom right of most keywords. So here we're dividing A by B, which means dividing 4 by 3. So let me just move the immediate window a little bit down so we can see the output of our work. Once again, I have my mouse in our Fun with Math procedure. I can just click this run button up here, and there we have it. 7 is 4 plus 3, that's this thing. 1 is 4 minus 3. 12 is 4 times 3, that's the asterisk operator. And here you'll notice that when we're dividing, we're getting the decimal point value because 3 does not go evenly into 4. I want to show you 2 more operators before we conclude this lesson. The first one is the exponentiation operator. So that's whenever you need to have a number and multiply it to the power of something. So for example, if I do debug print and I do A, and the symbol here is the upper caret. That's going to be Shift 6 on our keyboard. So what this means, remember that A is equal to 4 and B is equal to 3. This means 4 to the power of 3. 4 to the power of 3 in mathematical terms means 4 times 4 times 4. So again, it's the first number times itself, the number of times that we see represented on the right side of the caret. That's what exponentiation is in mathematical terms. So this is going to be 4 to the power of 3. 4 times 4 times 4 should give us 64. We see a whole bunch of output because I didn't clear my earlier stuff, but let me go ahead and do that. Let's once again execute this procedure, and there we have 64 appear at the very end here. Finally, one other thing I want to show you, this is probably the most unfamiliar one for people who aren't too experienced with programming. It's called the modulo operator, or modulus sometimes. So debug.print A, and this is actually an operator that's written like a keyword. So there's no symbol for it. There is a symbol for it in other programming languages, but in VBA, we use the keyword mod, and then we actually place the second value to the right of mod. So what modulo or modulus does, it's sometimes called the remainder operator. What it does is it returns the remainder of an operation. So if we were to take A, which is 4, and divide it by B, which is 3, it's going to return the remainder of that operation. So 3 goes into 3 evenly, and then there's 1 left over if we're trying to fit 3 into 4. So the modulo of this operation is going to be 1. 4 modulo 3 means how much value is left over once we complete all the division that we can. So when I execute this, we're going to get a value of 1. So there's 1 left over when we divide 4 by 3. If 4, for example, was 7, that would be a modulo result of 1 again. If it was, let's say, 8 modulo 3, 3 goes into 6, and there's 2 left over, so 8 modulo 3 would be a result of 2. And if there's no remainder left over, then the result is just 0. So if we have a number that's evenly divisible, for example, 9 modulo 3, 3 goes into 9 evenly, so the remainder is 0, so the modulo operation returns 0. All right, that's modulo. It usually goes hand in hand with division, but it kind of is interested in finding out the remainder rather than the actual number of times that one value goes into another. So these are the basic mathematical operations that are available in VBA: addition, subtraction, multiplication, division, exponentiation, and modulo. Get familiar with some of these symbols. Try practicing them a lot. A good recommendation I have is to actually write values onto your Excel spreadsheet, then try referencing them with the range, and then trying to actually perform calculations by referencing those actual pre-existing values rather than manually defining them here in our VBA. But that's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the date data type, which is used to represent dates and times in VBA. Now, whenever you're writing a date data type, it must be enclosed in hashtag symbols, both at the very beginning and at the very end. On most keyboards, you'll find the hashtag symbol by pressing Shift+3. And the date object is actually a pretty versatile object. It can handle a pretty wide range of years, almost 10,000 of them, going all the way back to January 1st, 100 to December 31st, 9,999. So a pretty big span of time that you can cover with the VBA date object. It's a little bit more expansive than Excel's date functionality. And the other cool thing about dates is we can declare them in a variety of formats because Excel and VBA are going to standardize them. It's able to recognize many different varieties in which we can write our dates, and it's always going to try to figure out how it can convert it to a more standardized format. Let me give you a few examples here. I'm going to create a new procedure here. I'll call it fun with dates, parentheses, close, open and close. Right here, I'm going to declare a variable. Let's call it birthday. Once again, the as keyword to declare a data type for my variable. This one is date, capital D. All right, so now birthday is expected to be a date variable. Let's go ahead and try assigning dates in a variety of formats to this variable. So I can begin with birthday. Remember, hashtag has to begin every single date that we declare. Even though we've declared the variable type, Excel needs this syntax to be able to function properly. So the first way we can do it is very much how we do it in the front end or the main interface of Excel. We can write the month followed by a /, the day followed by a /, and the year. So my birthday is April 12th, 1991. This is one way we can represent it. And remember, at the very end, I should put that extra hashtag. It's actually called an octothorpe, technically, at the very end. And that kind of encloses the date and allows the VBA interpreter to parse what it is that we're writing. So this is one way that we can declare a sample date of April 12th, but it's not the only way. For example, on the line below, I can reassign a brand new value to my variable. That's totally valid because variables vary. Their values can change. I can also do something like this. I can write 12 for my day of the month, followed by the full month written out, April, and then the year, like so. And this will work as well. One recommendation that I have for you is whenever you're writing your years, make sure to always use 4 digits when representing years. The reason for that is that Excel might get confused if you only use 2 letters, or 2 numbers rather. It might start thinking that it's in the last century or the current century. For example, if I put something like 36, Excel might think it's 1936 or 2036. The safest way to be careful is always just to put all 4 digits, and that will ensure that you don't run into any errors. Here's another way that we can write a date in VBA. On the line below, I'll do birthday. I still need to do the hashtags. Those are a consistent standard no matter how we're writing our dates. But I can also write out the full month, like April 12th, comma, 1991. Hashtag. You'll also notice on the line above, it's automatically been converted to the standardized format. And the same thing's going to occur when I press enter here. You'll notice that VBA is going to parse the way we wrote it and convert it to a standardized date. And it's configured to try to recognize as many possible date formats as it can so that it can always drive it to this standardized format. So you can either enter it in the way that it expects or enter it in any kind of conventional date scheme, and it's going to try its best to convert it. So you can see those 3 different variations have automatically been converted to the standard one right here. All right, and now we have a valid date, so we can go ahead and do something like output it to our spreadsheet. So I can do range a1.value. Let's put the value of birthday right there. Let's go ahead and run this procedure. I'm going to use my keyboard shortcut this time. I believe it's F5. Yep, F5. Let's go ahead and run this procedure, F5, and there my date appears in cell A1 in the traditional Excel format. That's the month followed by a slash, the day followed by a slash, and the full 4-digit year. I can use the date data type as well to represent times of the day. So right below here, I'm going to declare a new variable. I'm going to call it lunch. I'm still going to give it a date data type. Right below here, I'm going to assign a value to lunch. As always, we begin with the hashtag. And this time, I'm not actually going to give it a date value. I'm just going to give it a time. I'm just going to write 12:30 space PM. So that's 12:30, 0 seconds into the minute. That's what the last 2 zeros are there for. And each section, the hours, the minutes, and the seconds are separated by a colon. That's a conventional syntax, followed by a space and PM or AM. You can see there's no kind of standardization going on, but this is totally a valid syntax. And what I can do right now is, let's say, write in this value into range A2, let's say. So range A2 value, let's write in lunch in there. Let's execute this with F5. And there we can see 12:30 has appeared here as the time. What we can also do is, of course, combine dates and times. So let me declare one more variable here. Let's do sum event, also going to be a date. Let's assign a value to the sum event variable. Let me also scroll down so we can see this a little bit easier. Sum event equals hashtag, and we can combine both of these syntaxes. So I can do something like, let's do June 30th, 2015 at 9:25:36 space AM. Close everything with the hashtags. That's a pretty conventional way to write a date and a time. Now let's go ahead and write this value to cell A3, range A3.value equals sum event. Execute this. And there we see the complete date with the time written out. So this singular date object can represent date, it can represent time, and it can represent both date and time. Of course, right now we're not doing anything particularly useful. We're just kind of writing it to the sheet. But you can imagine what we can do with this feature as soon as we have something like a spreadsheet full of dates. We can take them, we can manipulate them, we can add time, subtract time, find out the certain day of the week, things like that, and then write that value back. Do some kind of processing or analyzing of the data we have using all of the date functionality that's available on this object, which we'll explore a little bit later. But that's the date data type, yet another option available to us among our many data types. And that's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the variant data type, which can be used to store any kind of data type. In fact, a variable that's declared as a variant can store a number and then be assigned a Boolean and then be assigned a string, and no errors will be raised by the program. A variant is sort of like a chameleon. It can morph into whatever data type is needed by the program. A variant is also the default data type for all variables that we declare without a specific type. So it's what VBA relies on to be able to gain versatility and flexibility with a variable that the user has not explicitly defined to have a data type. As it turns out, we can also explicitly tell VBA that we want a variable to serve as a variant data type. A common question that people have is, if variant is so flexible, why not just use it all the time for every single variable? There's two reasons why we want to avoid this. The first is memory allocation. So when we have this flexibility and this dynamic nature to a variable, behind the scenes, VBA needs to take up more memory to represent this data type that can basically be anything. Now, some VBA developers say, again, in today's day and age, with the speed of computers, that memory usage isn't really a big concern. With that said, even if that's true, we want to get into the practice of establishing these best practices and these good habits. The more that we explicitly use the kind of data type that we want for a program, for example, saying that a variable will be explicitly an integer or a long instead of a variant, the more that we kind of makes logical sense in our brain how the program is designed to work. The program becomes structured a little bit better and a lot easier to understand and debug, especially if you can imagine another programmer reading your code. If every single variable that we declare is just a variant, how are they to know exactly what each variable is supposed to represent? In comparison, if we tell them that something is a long, they intuitively have a sense that the variable is going to be storing some kind of number, so some kind of numeric representation. So a variant makes the program less logical and more difficult to debug later. So it shouldn't be used just kind of haphazardly whenever you want to, but it does have certain use cases. For example, whenever there is uncertainty about the data that is being stored in a variable. For example, you might ask the user for input, but you might not be sure how the user is going to give you that value. They may enter a number, they may enter a string, they may enter something else, and whenever you want a data type that is flexible enough to adjust to any kind of uncertainty, that's what variant is perfect for. Let's go ahead and define a procedure here in my Visual Basic Editor. I'm going to call it chameleon. And what I'm going to do here is just define a variable or declare a variable called a. And a is going to be a variant. Now, as we know by now, if we don't give a variable a data type, if we leave out the as keyword, VBA is going to assume that the variable is going to be a variant. So this is enough, but let's go ahead and be explicit here by writing as and writing the actual variant keyword just like we would for any other data type. So a now is variant. It can store anything we want. So for example, I can assign a Boolean value to a. And what I'm actually going to do below here is I'm going to use debug print, and I'm going to rely on a method we talked about a little bit earlier called typename. Typename is a built-in method or function that accepts some kind of variable, and it's going to tell us what data type that variable is currently. So I'm just going to give it a, and if we execute this procedure right now with F5, we can see in our immediate window that right now a is being represented as a Boolean. Notice that we declared a right here as a variant, but variant is a flexible data type that can adjust to whatever we need it to be. So right now at this stage where a is equal to true, variant has evolved or morphed into a Boolean data type. Let's continue this process and assign something different to a. Let's now assign a long or an integer, let's say the number 5. If I repeat the exact same process and I ask for what the data type is of a at that juncture, if we execute this now, we're going to see a totally different value. We can see that now the variant has morphed from a Boolean to an integer. So it's dynamically adapting, almost like a chameleon, to store whatever is needed. If I continue this logic onwards, let's say I change it to something like a floating point number like pi 3.14. Let's just debug print that. And right below here, let's go ahead as well and give it an actual string value like hello. And once again, debug print type name, give it the value of my variable. We're going to see 4 completely different values here when I execute with F5, Boolean, integer, double string. So that's the whole point of a variant. It can adapt dynamically, flexibly to whatever we need it to store. Again, this isn't something that you should use all the time. It's a lot of power to behold, and you might be tempted to say, okay, this is great. I don't have to worry about thinking about what it is that I'm actually going to be working with in my program. However, as I mentioned, that's not a best practice for developers. You do want to think about what each variable is going to be storing. You need to think about whether a variable is necessary in your program. You need to think about how its value is actually going to be calculated. So variant is sort of like a little bit of a cheat tool. It seems like it makes things easier, but it really burdens you and makes it more difficult for you to become a better developer and actually have to more critically assess how your program is going to run. So avoid using this data type unless it's necessary, unless you can think of a situation where you're not actually going to know what a variable is going to store. And in that case, when you need that level of flexibility and versatility, at that point you can stick with an actual variant data type. So far in this section, we've explored a lot of different data types. We've taken a look at longs and doubles and booleans and dates and variants and so on. As it turns out, we can actually declare variables that represent objects within the Excel object model. So we can actually have variables that reference things like worksheets and workbooks and ranges. The reason we might want to take this approach is because it simplifies the process of creating references. Rather than having to write out a complete reference each time, we can have a variable represent that relationship and then rely on the variable to establish that association. Let's take a look here in our actual VB editor. I'll begin here by declaring a procedure. I'm going to call it object variables. The syntax for declaring a variable that's going to represent an Excel object is pretty familiar. It's going to be the dim keyword followed by the name of the variable. Let's say here I want to represent a Excel workbook object. I have to first come up with a variable name. Let's do WB, then the as keyword, and here instead of putting one of our familiar data types, I'm actually going to put an actual object within the Excel object model. So we know we have the concept of a workbook, so I can simply enter workbook. As another example, let's say I want to create a variable that's going to represent a worksheet object. Let's give that variable a name of WS. Once again, we're going to use the as keyword and then the type of object that that variable is going to reference or represent. So this time we're going to have a worksheet object. One more example, let's say I want to have a variable that's going to eventually be storing or referencing a valid range or a collection of cells. So let's call that variable box, and it's going to represent an Excel range object, so as, and then the exact name as it is in the Excel object model, range with a capital R. So now we've declared the variables, but we still haven't assigned them actual values. The way we do that is a little bit different when it comes to objects. We're still going to use the equal sign. However, this time we need to prefix our variable name with an additional keyword, and that keyword is set with a capital S. So let's assign the WB variable. We have to use the set keyword, and this is only when we're assigning an object. You don't need it if you're doing a plain data type like a boolean or a long or a string. But whenever it's an object, you must use the set keyword before the variable. So set WB equal, and remember that this has to be a valid workbook object. So how can we get a workbook? Well, we know that workbook objects are stored within the workbooks collection. So if I target the workbooks collection, and let's say I take out the first workbook, which is the only one we have open here, this is a valid syntax. And what this is going to do is assign the workbook object, the only one open, to the WB variable. Now, the object that's represented on the right side of the equal sign has to be the exact type of object that we told the variable it should expect. So WB expects to be a workbook. So if we give it something like this, which is a workbooks object, this is going to throw an error when we run the macro. It has to be the right type of object. So now we're referencing a workbook. That's exactly what WB is declared as, so we're not going to run into an error. Let's say I now want to set the WS variable, which represents a worksheet, to the only worksheet I currently have, which is sheet 1. How can we do this? Well, the first way we can do it is doing something like this. Set, again, WS, that's our variable, equals, and let's say I target the first workbook I have open. Within that workbook, I have a worksheets object. That's a collection object. We can index into it to extract a specific worksheet, and that's going to get us sheet 1. Now this is completely valid, there's nothing syntactically wrong, but if you take a look at this line and the line above, you should see some duplication, which is that we're consistently referencing the first workbook in the workbooks collection object. We don't need to do that, because if you think about it, this WB variable is already pointing to that workbook. It already represents that object. So how can we simplify the syntax? What we can realize is that this is the exact same object that the WB variable is pointing to. So we can actually replace this workbooks1 syntax with WB. You can almost think of it as a find and replace operation. Whenever VBA is going to run into the variable WB, it's going to figure out what it means and what it's storing, which is going to be a single workbook object, and that's what's going to be substituted here. So hopefully this is going to give you a sense of how variables can be beneficial when they're pointing to Excel objects, which is that it allows us to write a lot cleaner code because we don't have to write those references each time. Let me give you another example with box. So let's say I want to set box to a valid range object. I can, of course, do something like workbooks And then let's say I want to reference the first one, and then within there I want to reference the first worksheet, and then I want to reference a range with the cell of B2. This is totally valid. There's nothing syntactically wrong with this. But again, workbooks right here is being represented by WB, but even better, this worksheet that we're extracting right here, this is already referenced by WS. WS is relying on WB's knowledge of which workbook it is, and WS is simply going one step further. So if we replace everything here, this first section right here, we can take that and replace it with WS. Because remember, WS knows what workbook it's referencing, and now the variable is just going to be substituted with that worksheet. So now our syntax is a lot cleaner and a lot lighter, and we've accomplished the exact same result. And all of these are now properly referencing the exact object types that we've declared for the variable. So we can actually do things with them. For example, with a workbook, WB is a valid workbook object. We know that a workbook object has a name property, so we can execute this and see that we're going to get the name of the file. That's proper. This is only to demonstrate that we're not running into any kind of syntactical error or any kind of bug with our code. WB is actually referencing a valid workbook object because we've extracted it right here from the workbooks collection. Similarly, we know on a worksheet object, which is what WS represents, we have a name property. That property can be given a new value to overwrite the name of the worksheet. So let's say we want to change sheet 1 to, let's say, fun times. We can execute this. When I execute this, we can see the value has changed right here in my Excel interface. And finally, let me give you one more example. We know that box represents a valid range object, specifically the range of cell B2 on this worksheet now called fun times. So what we can do is say box, that's a valid range object. So anything that we see available here is going to be methods and properties on range. We know that range objects have a value property, so we can set the box's value or the range's value to something like 5. This is cell B2, so it should appear right here when I execute this macro. And there it is, there's number 5. So we've used variables in this lesson not to store plain kind of primitive data types, smaller things like numbers and strings. We're now using these variables as pointers to refer to these valid objects in the Excel object model. As you can see here, it allows us to write code that is a lot more concise because one variable can retain a reference to its parent, for example, and know exactly what it is that it's referencing in that hierarchy. We don't have to write that fully qualified reference each time and specify where we are in the workbooks, where we are in the worksheets, etc. And right now, we only explored 3 different objects, but you can actually declare a variable to be of any Excel object whatsoever. So as we explore more objects throughout the course, feel free to experiment and set a variable to any one of those objects. You can manipulate that object and perform the same kinds of methods and access and overwrite the same kinds of properties, but instead of providing the full reference each time, you can simply rely on the variable that's pointing to that object. In this lesson, I want to take a look at default values for declared variables. So as we know, the dim keyword instructs VBA to set aside memory for a variable. As it turns out, when a variable is declared, VBA actually assigns it a default value. So before we use the equal sign and give the variable its actual value that we want to give it, VBA automatically assigns it a predefined value. And the kind of value that it grants is based on the data type. For a string variable, that's going to have an initial value of an empty string. For long and double variables, those are going to initialize to a value of 0, and Boolean variables are going to initialize to a value of false. Let's take a look at this in the body of an actual procedure. I'll define a procedure here called default values, and I'm just going to declare a couple of variables up here. Let's create a string. Let's make it the variable s, dim s as string. Let's do a long. I'm going to use L for that. Dim L is long. Let's do a double, dim D as double. That's a floating point number. And finally, let's do a Boolean, dim B as Boolean. Short and sweet variable names. So, as I mentioned, we haven't assigned any values to S, L, D, or B. So what's going to happen when we actually debug print them out? Well, as it turns out, VBA is actually going to assign them default values, and we can take a look at what those are below. So let's output each one of those variables and execute with F5. There we go. Right here, we're not seeing anything, but that's because it's an empty string, and an empty string is represented by white space. That's the actual output of this debug.prints. That's a string. So a string variable initializes or is defaulted to an empty string. No spaces, no characters, no numbers, nothing. Any kind of numeric variable like L or D, which is a long and a double, a whole number and a floating point number respectively, those are given an initial value of 0. And a Boolean variable, here we store it in B, is given an initial value of false. So we have to be very careful here, because if we're ever running into code or bugs, it might be due to this issue that we forgot to give a variable its default value, or rather our own assigned value. Many times we may be declaring a lot of variables at the top of a procedure, like 10 or so variables, and we may forget to assign a variable its initial value that we want to give it. And later on in the code, we may use it, and we may not encounter any kind of immediate bug because that variable is storing a valid value that can actually work in the context of our code, but it's not going to function as intended because the value it's storing may not actually be what we expect it to be. We're not going to run into any kind of error if we, for example, use S, L, D, or B in some kind of calculation, because it does have a valid value. It's just not what we're exactly looking for. So we have to be careful. Just remember that whenever you declare a variable, it is given a default value. Empty strings are assigned to the string data type. A 0 is assigned to the long, double, and any other kind of numeric data types, and a false value is assigned to the Boolean data type.